you, Maya. This session in the afternoon, we will, from 1:30 until 2:30, cover data visualization and making graphics in R. We'll have another 15-minute break. And then from 2:45 to 3:45, we'll talk about using R as a GIS. And then we'll spend any remaining time wrapping up and talking about how you guys can move forward and continuing to learn R on your own. Also, quick shout out, if you are on Twitter, we are using the hashtag Tampa Bay Open Sci for open science, which is right behind me on the whiteboard. So feel free to tweet away and at us and pound us or hashtag, whatever the kids say. We highly encourage that. So with that being said, welcome back to this afternoon in our R session. So we'll just jump right into it. All right, visualization and graphics. I said before the break that this is my favorite thing to do with R. I love making graphics. I think it's incredibly important to look at your data as opposed to just wrangling it, which is often, as I mentioned before, a prerequisite to creating other things like graphics or models. So now this is the next logical extension to your data analysis workflow. So going back to this graphic that I showed in the very beginning, again, this is your typical data analysis workflow, and right now we're somewhere in this vortex of understanding where we want to start creating graphics of what we're doing so we can understand our data. So we're going to be, again, using the tidyverse for this, the GGplot package, which is a huge part of graphing in R. We'll be going over that a little bit. And we'll also talk a little bit about using base R, so the plotting functions that come out of the box with your R installation. And I'll tell you why you might want to use one or the other, I guess, based on my own personal workflow. All right, so after this lesson, again, this is the fire hose of information, so you're not going to be an expert, but you should be able to answer or find answers to the following. What can you do with base R plots? What are the requirements for using GGplot? What are geomes? What are facets? What are themes? And if we have time, how do I save a plot? Because every good plot deserves to be saved. So when I first started using R, I was using base R. This was before GGplot was around. But I'll say that once GGplot hit the scene, I almost stopped using base R completely. However, I still think base R graphics are somewhat useful for exploratory analysis. In other words, quick and dirty plots that are not necessarily polished for publication or even sharing with colleagues, but just a really simple way to start looking at maybe the spread of your data with histograms or making scatter plots. So I'll show you some of those examples, and we'll transition into GGplot. And I have to make an advance apology for this exercise. We're still using the fisheries data set for our actual exercises in this lesson, but all of the examples in the lecture material comes from a data set called MPG, which is a really, really common data analysis example data set that is used in a lot of tutorials. So if you've seen this data set before and you're tired of it, I'm sorry, I'm tired of it too, but it is actually a really good data set to just explore interesting relationships among cars. So we'll be using that for some of our examples. And this data set comes with tidyverse, so you do have to load the tidyverse to access the data set. So I will pop over to RStudio. Make a new section in my script. Make sure I have tidyverse loaded. Okay. And then I believe, yeah, so whenever you load tidyverse, you get a whole bunch of example data sets come with it. So MPG is already there. So we will see that this is showing us basically mileage statistics and engine characteristics and drive characteristics for a lot of different types of cars. If you're into cars, great, this is the data set for you, but yeah. So let's just make a plot of my example, which was HWY by DISPL. So we'll use the plot function. This is the workhorse of base R plotting graphics. And I'll explain what this notation means in a minute. We'll run that and we see a plot show up on the bottom right panel where we have our plot window. So this shows highway mileage on the y-axis versus engine displacement. So we see what looks like a negative slope there. So the larger the engine, the more it displaces, the less fuel efficient it is. So that makes total sense. But we're not here to look at this particular data set and understand what it's doing. I'm here to explain to you how we made this plot. So this is the plot function. We can look at the help file, !plot, generic XY plotting. That shows up in the bottom right pane there. Save that for you guys using the live coding script. And it says the required arguments are an X variable and a Y variable, and then this ... guy. This is basically saying I could accept any other arguments that go to other functions that are used within the plot function. And I'll explain a little bit about what that is in a minute. But here we have made a plot using the formula notation, which is a little bit different than how the help file explains it. But this bit right here is a very common way of writing out formulas in R. It's used for plotting function, it's used for modeling functions, but this is the same thing as saying Y versus X. So this tilde thing can be thought of as versus. So we're plotting highway versus displacement. And in order for the plot function to know where those variables are from, we have to supply this additional argument to data. So it knows that it's using the MPG data set. So that's all well and good. If we did want to use this XY notation, we can also do that, but we have to do an extra step where we call the variables directly. So this is a new sign you haven't seen before. This is a $sign that basically lets you pull out a column from a data frame. So here's my MPG. If I wanted to pull out the displacement column, I could use $sign displacement, and there we have it. So this is literally the X values and this help file that we want to plot. And then same thing for highway. We do MPG $sign highway. And in this case, we don't need to say data equals MPG because we're giving it the data directly as a vector into the separate arguments for the plot function. So another way to do it, but now we see that our axis labels are a little weird. I mean, again, this is not a finished product of a graph. The labeling is a little off, it's a little messy, but gives you a good idea, a quick idea of how to visualize the data. All right, so we can clean this up. If you do want to make nice looking graphics in base R, it's totally doable, but it is kind of a little bit like stitching together a lot of different pieces, and it can be kind of tedious. So here I'm making the same plot. So this bit of code is the same as the first example, but now I'm passing additional arguments. So going back to the help file, these ... guys, you can actually see the documentation here, which ones it could accept. So main is saying I'm going to change the title of the plot. xlab says I'm going to change the x-axis label, and ylab being I'm going to change the y-axis label. So hooray, now we have a kind of better looking plot. The axis labels make a little more sense. There's a descriptive title, and we've just kind of gussied it up a little bit. Let's see. So if you are using base R graphics, it's good to familiarize yourself with the par function. This is kind of like the master function that defines a lot of the visual characteristics of a base R graphic. And that ... that ellipses thing and the plot help file, this guy basically means that you can pass arguments to the plot function that apply to the par function, which again is that function that can handle a lot of the visual aesthetics of the base R plot. So I just want to bring this up because when I first started learning R, I messed around with this par function a lot to make the graphs look a little bit better. So if you look at the help file for par, you can see there's like, I don't know how many arguments there are, but there's a ton for formatting how things look in the plot. Some useful ones are like the CEX argument that affects the sizing of the points, for example. Call argument is for the color of the points. PCH is the point type, squares, triangles, circles. Family is for like font type, serif, sans serif, whatever. So I'm just going to show you another example of altering some of those visual aspects of the plot using those additional arguments. So here I said it's the same as the one I just did, changing the titles, the axis labels, but now I made the colors blue, points is 18, and then the point size a little bit smaller from default. I think 1 is default, so 0.75, a little bit smaller, and then changing the font to serif. This PCH is like, I couldn't tell you what 18 is. I mean, it looks like diamonds, but if you do a quick Google search of R PCH, the symbols is the first one that pops up. You can see what those are, and this is buried in the help documentation somewhere, but I always Google this when I'm trying to figure out what the points are. So there's your nice guide there. So that's all I want to say about these scatter plots. You can also, I guess one last thing about the scatter plots, the arguments that I use, the optional ones that go to that par function, you can also assign them outside of the plot function themselves, which sets a global theme for a base R plot. So that's just another way you can handle that if you're making a lot of plots in base R and you don't want to use these arguments every time you make a new plot. So you can set like a global theme this way. That being said, GGplot does this a lot better. So I'm questioning why I'm telling you this at the moment. The last thing I use for base R with plots is histograms. Scatter plots are good to look at general relationships among variables. Histograms are also good for looking at the distribution of one particular variable. So what's the central tendency look like? What's the spread of the data? And it's very minimal code to run this. Actually, I'm not even going to copy and paste. I'm just going to type it in. So for histogram, MPG, we'll look at city. So that's mileage that these particular cars get in the city. And so, it looks like average is around 15, ranges from less than 10 to over 30. So I just like to do this to get a sense of, whether or not this, particular variable is normally distributed or there's outliers, that sort of thing. So that one is quick and easy to understand. The breaks argument for that one basically sets the number of divisions in the bins for the histogram. So that could be useful if you want a finer resolution of the categories that make up the counts in the histogram bins. All right, that's way too much time spent on base R. So I'm going to let you guys loose on exercise 9, which is making a simple scatter plot of pinfish catch over time. So you should have the fish stat data set already loaded from last time, but now I just want you to take that data set, make a scatter plot using the formula notation and the data argument with fish stat. So I'll put 5 minutes on the clock and let you guys have at it. All right, so that's 5 minutes for exercise 9. That one hopefully didn't throw too many curveballs at you. It's pretty simple. It's kind of just copying and pasting the code with the MBG data set and putting in the fishstat data set. So let me just read that in again in case you lost that or restarted R during the break. And then we'll just do plot. What do they say? Pinfish. Remember, this is using the formula notation. Tilde, so pinfish versus sampling date. Yes, sampling underscore date. And then if we're using formula, remember we got to tell it where the data are coming from. And I'm going to give it a title. Catch over time. And so this is all stations. So realistically, this is not a super useful example because it's a huge mashup of a lot of places. But this gives you an idea of kind of roughly what the population of pinfishes look like over the last 25, 30 years. So pretty simple, but that's base R. So I do want to spend most of the time in this lesson talking about GGplot. As I said, GGplot has only, well, let's see, I think it's over 10 years old now, so it's been around for quite some time. But it's the most popular plotting library that's available for GGplot, and for R. And one of the reasons it's so popular is because it follows a philosophy called the grammar of graphics. That's where the GG comes from. And this is a departure from most plotting functions available in R because there's a syntactical structure to how these plots are made. It's almost like parts of a sentence that have different pieces that together they mean something, but by themselves they're just elements that you would develop for a specific purpose. So understanding this grammar is the biggest learning hurdle for a GGplot, but I'm going to walk you through this and describe to you the main parts of any GGplot graphic so you can understand how the pieces fit together and what the required parts are to get you thinking about how this is a useful tool. So every GGplot object starts with the GGplot function call. Here we're just saying, I'm going to make a GGplot with the MPG dataset. So by itself, this does really nothing. It doesn't make a plot. It just sets up a structure for the plot. So think of this like the house. So I just executed that, ran that in the console, and nothing came up. But now with this, GGplot is sort of ready to start taking other pieces that are part of that sentence structure, that grammar. So in the next step, I'm going to say, now that I've started my base plot, I'm going to add a geom. Now a geom, there's several different types of geoms. There's points, there's lines, there's tiles, there's contours, you name it. GGplot has several dozen of them, but this basically says the type of, or how you want to show the data in your plot. So this is going to make points from the data. So I have to add this to this base GGplot object using the plus sign. And this is a little confusing if you're first learning R. This is the only function, or rather only package in R where you use plus signs to join the functions together. So it's not like, actually think of it like a pipe, because we talked about pipes last time, but GGplot was made before pipes. So they had to use a plus sign to say, do this, then this. So just remember, when you're making GGplot and you're combining the different pieces, use plus signs. All right, so we have our base plot, then we have our geometry, or our geom. We're saying make some points. And then the next step is to map parts of this data set to the aesthetics in the plot. So the aesthetics are ways to tell GGplot which pieces of your data set go to what part of the plot, or the aesthetics of the plot. So we have this additional argument inside of geom point that we're calling mapping. And that takes another function, the AES, the aesthetic function, that says, okay, if I'm going to make a point layer, I need an X value and a Y value. And these are names of columns in this MPG data set. So we're mapping the display or displacement and highway fuel mileage columns to the X and Y aesthetics in the geom point argument. So all GGplots start with this function, and it needs a data, and it needs to know how the data are mapped to the plot aesthetics and which geometry you want to plot. So that's a lot to think about if you've never been exposed to this before, but that is the foundation of every GGplot: data, mapping, and geometries in aesthetics. So let me just show you what that looks like. I'm going to run that, and we get a scatter plot that looks just like the one we made with base R. Now, there's again a lot more steps to creating this base plot, or this simple scatter plot, but hopefully in these next examples you'll see how this is valuable for building graphics versus just doing things brute force with base R. So there's our graph. I also want to mention that the mapping, the aesthetics, where you say what part of the geometry or what part of the data is mapped to the geometry, can go up in this global function call. Now, there's a reason why or why not you would do this. For this example, it doesn't make a lick of difference, but I just want to show you that you could do it either way. Here's another geometry type. This is a line geometry. In this case, it's connected all of the points continuously, which doesn't necessarily make sense for our data set, but just to show you that you could just swap out one geometry for another just like that, so long as that geometry takes these mapping aesthetics here. And also notice that we didn't have to do mapping equals AES in that function call. It's just shorthand if you want to save yourself some typing. Here's another geometry, geom count. This is like kind of how many observations are at each value to show you kind of a density of the distribution. Here's a literal density plot, so contour plots of where the bivariate relationship falls out. Again, just X and Y aesthetics for this one. And I wanted to show this example. So here's another geometry, line range, where if we try that with our aesthetics, we get an error. It says geom line range requires the following missing aesthetics: Ymin, Ymax, Xmin, Xmax. So, okay, first thing I would do, I'd say, well, what's up with this geometry? So I go to the help file. And then I could scroll down and I could look at, okay, mapping, data, yada, yada, yada. Aesthetics. Okay, so this geometry requires X or Y, Ymin or Xmin, Ymax or Xmax. Everything else is optional. So this help file is telling me that I need to supply additional pieces of information in order for GGplot to use this geometry. Now, it turns out this data set is not appropriate for a line range geometry. That's more, this line range is kind of like error bars or different line segments that are discontinuous over the data set. So we wouldn't want to even use this geometry with this data. But I just wanted to show you that some geometries require different aesthetics in addition to X and or Y. So just be aware of that when you're trying to plot different geometries. Yeah, and so geom point, it's a little hard to tell, but only X and Y are required. Everything else is optional. So this is just showing you really simple. You can map other aesthetics. So I'm gonna show you this one because it's worth looking at. So this is the same plot before, but we have this other column in our data set drivetrain, which says whether or not it's a two-wheel drive, or I'm sorry, front-wheel drive, rear-wheel drive, or all-wheel drive. And I just know that because I've spent way too long staring at this data. But here's the drive column. It's a categorical value. We can map that to the color aesthetic to basically color the points differently by drivetrain. And so same plot as before, but now we have a legend and color code for the different drivetrains. So an interesting data set, because not only do we see a negative relationship between engine size and highway mileage, but there seems to be some agreement among whether it's a front drive, rear drive, or four-wheel drive car. So pretty cool. That, by the way, is really hard to do with base R. Not impossible, but a little more challenging. Here we're mapping size to the displacement column. So this is just changing the size of the points relative to the x-axis. Not really a useful plot, but just to show you how that could be done. Here we're mapping shape to the drivetrain. So actually it's worth showing that one too. So here we had color. We can also do shape equals drive, plot that. All right, cool. So it's a little redundant because we've mapped both color and shape to drivetrain, but sometimes you might want to do this if you want to really visually distinguish different categories in your data set. So you'll see that color varies as well as the shape type by drivetrain. And of course, if we don't want to map color to a variable, we can always just explicitly say what color we want the points. And so in this case, this color is outside of the mapping aesthetic function, which means don't map color to any attribute of the data set, just make the colors red. And so this, it's a way to kind of override the aesthetics if you prefer to do it that way. All right, so let's do exercise 10. What I want you to do is reproduce the same plot you made last time with base R, but do it with GGplot. And if you have time, try the third part of this question. It's an important component that I want to mention about GGplot, but if not, we can go over that together. So I'll put 5 minutes on the clock and you can have at it. All right, so hopefully that wasn't too challenging. You can literally, well, if I'd have saved that, you could have literally copied and pasted the examples for the MPG dataset. So I'm going to replace MPG with fishstat, map X to sampling date, and then Y to pin fish, and then run that. And this is more or less the same plot that we had with base R, but now created with GGplot. So the last step that I had in that lesson was to convert the scale on the y-axis so you can get a better sense of what these counts are doing over time, because these are highly skewed data where there's a lot of low values and a lot less high values. So it's a little challenging to see what's going on. So there's an entire family of functions in GGplot that deal with scales, and we don't have time to go into all of them, but I wanted to show you, well, you can see them there. So scale, I mean, there's tons. But these basically affect the characteristics of like the axes, the color gradients you're looking at, the transparencies, mostly related to plotting aesthetics, but still can be really useful for enhancing what you see in your actual plot. So this one in particular, scale y log 10, will convert the y-axis to log 10 scale. And there you have it. So it's now in log scale, 1, 10, 100, 1000. That's a base 10 log scale. And we can see there is still kind of a positive trend over time, but now we see, we can get a better sense of the distribution because now it looks more visually appealing to us. You do see this warning message that says the transformation introduced infinite values in the y-axis. That's because we have 0 values in our data. And if we take the log 10 as 0, we get infinity. So this is just GGplot's way of telling you, hey, your data don't really sometimes agree with what you're trying to do, but I'm going to do what you told me to do anyway. So that's how you interpret that. And just be aware, warnings are generally good to read and try to understand what they mean, because sometimes it does affect what you see or what R has done to your data, but it doesn't necessarily mean there's a critical error in your code. So just try to be aware of what they're saying. All right, so the last thing I want to tell you, I guess second to last thing I want to tell you about GGplot is how to modify plot components. So what we talked about before the exercise was really more about how to create the plot, the geometries, and a little bit about some of the scale functions. So a lot of times you'll want to change the actual visual appearance of a plot, just like we did for base R, based on journal requirements or personal preference, or any way you can make the visual display of your data more appealing. And so the way you do that in GGplot is with the theme function, and this defines everything under the sun for what the visual characteristics, independent of the actual data you're plotting, look like in GGplot. So here, this is the same plot we had before, but now I'm adding the theme function where I'm saying put the legend on the top, remove minor grid lines, so things in between the major lines, and I'm making the background of the panel light blue. Not really a pretty looking plot, but just to show you how that can be done with theme. There's like hundreds of options for what can go on theme, and so if you look at the help file for theme, you can get a sense of what they are. But to save you time, you can use prepackaged themes that come with GGplot. So here's the theme BW for black and white. So I'm just going to do this on our pinfish plot just to show you what that looks like. So now instead of that classic GGplot gray background, we see a black and white background. We have, I'm just gonna copy and paste these so you guys have them. Theme minimal, if you want a rather minimal looking plot. Theme gray, I think that's the default. Yeah, there's quite a few, and there's even libraries. Yeah, there's minimal, classic, BW. Yeah, and there's even whole supplemental libraries you can download. I think there's one called GG Themes that has several supplemental themes that you can use with GGplot. I won't show you them now, but for example, they have a theme that looks like the Wall Street Journal. So you can make your plot look like it was from the Wall Street Journal. And that's just, again, a quick and easy way to update your plot without tinkering around with the individual theme components. What is a nice feature about themes is you can specify a global font size and font type with these additional arguments. So now I've made the font bigger and made it a serif font. So that is a really handy way to globally change the appearance of your fonts with themes. All right, so that's a little bit about themes. I want to talk about a little bit about how you can use GGplot to make summary statistics in your plot. This is actually, with base R, a lot more challenging to do. With R, it's a lot easier to do. And then there's essentially, there's a handful of functions that do this, but the workhorse of it is stat smooth. So I will go back to RStudio and show you what that looks like. So I'm going to go with my data set here with MPG, with the point scatter plot, and add stat smooth. Run that. And we get a bunch of low S smoothers, so locally estimated polynomial regression lines, which might have some actual meaningful interpretation or could just be some overfit to the data. But point is, this is a really quick way to put summary lines on your plot. Notice that actually this is a really important part about GGplot related to the grammar of graphics here. We get a separate smooth to every group that we've defined in our data set with these mapping aesthetics here. So again, we mapped color to the drivetrain and shape to the drivetrain. If we don't have that, we take that out. Actually, I'll just copy and paste that. If we don't have that, we get a different looking plot where we have one smooth through all of the data. So again, this is a key thing to know about GGplot. The geometries and the statistical summaries all inherit the mapping that applies in the global GGplot function call. So when I make the color something or the shape something, the point geometry picks it up as well as the stat smooth. If I wanted only the color to apply to the points and the smooth to apply to everything, I would use the aesthetics only in geom point and say color equals drive and not put that into stat smooth and see what that does. I'm not writing good code. Okay, so I'll explain what just happened in a second. All right, so there we go. So this shows color for the points mapped to drivetrain, but the stat smooth is through the whole data. Now that error that you just saw was me being sloppy in my R code, where I took all of the aesthetics and put them only in ggpoint. Now remember, stat smooth requires aesthetics as well. So when I took the aesthetics out of the global ggplot call and put them all into gmpoint, it didn't know how to apply that stat smooth because it didn't know what the y variable was, what the x variable was. Now that they're both up here in the global plot call, these aesthetics are passed down to the point geometry and the stat smooth geometry, and only color, because it's in the gmpoint aesthetic function, is mapped to the points. So hopefully that makes sense, but that is a really important thing to know about GGplot, and is a, I think, stumbling block for many when they're using these for the first time. All right, before I let you loose on the last exercise, I want to just cover one final function that I find incredibly useful for GGplot. And this is the family of facet functions. And so this is a really quick way to make multi-panel plots, where each plot is each panel in the plot is a subdivision of your data, where in this case it's a categorical variable in his drivetrain here. So hopefully that was clear what I just said, but just to again reiterate what that is. So here again is our plot with everything. So I've made a scatter plot, mapped color to drivetrain, and I have a smooth. In this case, I specified a linear model smooth as opposed to a low S. And I've added this bit on here that says, okay, now take this plot and make several individual panels where each panel is one category in drivetrain. So I'm going to have 3 individual panels from this whole larger plot. I'm going to have 3 columns, and I'll tweak that in a second to show you what that argument does. And I'm going to let the scales be free, meaning I'm going to let the y-axis scales and the x-axis scales vary between the plots. So if I change these, actually just remove the scales argument and said I want 2 columns, now we have 2 columns and the scales are fixed. So the y-axis limits are the same between the panels, and the x-axis limits are the same as well. And we have 1 panel per type of drivetrain in the data set. So again, super awesome, simple way to look at relationships among variables if there's a grouping factor among them that you think is affecting your ability to interpret those relationships. So facet wrap lets you do that really quick. So we're almost out of time, so I'll let you loose on the last exercise, and I'll just, after that, just tell you very quickly how to save a plot, because it's important to do that, and then we'll take a break. So in this exercise, I'm having you use the same plot you had last time. So that scatter plot of pinfish catch over time. You can use the log transformation if you like, but then I want you to add a theme of your choosing, add a smooth function, and then if you like, you can facet those plots by different gear types. And so 5 minutes on the clock. I'll let you have at it. All right, right at 2:30. So I went ahead and I typed in, I think what I told you to do in the exercise. So uh, this is our plot we had before, pinfish over time with the scale y, log 10. I had to move the mapping up to the global GGplot call because stat smooth and facet wrap, um, basically everything but the theme requires these X and Y aesthetics. So um, I added the minimal theme and I added stat smooth with the linear model LM method, and then I made a facet wrap with the gear column, and I said give me three columns there. And so we get a bunch of warnings. Don't worry about those. It's just things about um, the infinite values with log transforms, and this removing is basically, it says there's 1,375 values with zero that couldn't be plotted because in log space they're infinity. So that's just GGplot doing its diligence, telling you what's going on there. So there you have it. We're on break, but I just want to say if you want to save this plot, you can go up to export, save as image, change the width and height in pixels, and save it to anywhere on your computer. So that's one of a few ways to save graphics in R. That is the easiest way, but I encourage you to read the rest of this in your own time about some of the other methods. So we'll go on break now, and we'll reconvene at 2:45, and we'll wrap up for the day with GIS in R.